And today in the lecture I will mainly concentrate on Bertrand Russell's his how he saw logic in the scheme of mathematics and interrelations of mathematics, vice versa, within the context of the how Frege in his foundations of arithmetic, how he addressed issues of arithmetic, and how he tried to logicize arithmetic in his program of things, in his scheme of things, the in his book Foundations of Arithmetic, how he has given the arguments which he has enamored or he has given in favor of how we can arithmeticize logic also. For example, the questions, for example, the answers to the questions are raised about, for example, the nature of arithmetical truths, whether they are posteriori, they are a priori, they are synthetic, or they are analytic. So, so the previous debate of Euclidean and non-Euclidean geometry, in which the Kantian understanding of taking extending whether we can extend the a prioriness of the synthetic a prioriness of Euclidean geometries to non-Euclidean geometries, although unsettled, but Russell, in the way he addressed that questions in his foundations of geometry. So in the same way, how he also tried to address the developments in logicization of arithmetic within his own system. So he extended the previous works of maybe Frege, and maybe the larger questions of how Leibniz tried to see the in the definition of logic, and the way he said the distinction of analytical, the in how he characterized analytical statement was basically where the difference between subject and predicate would get dissolved, while in case of Immanuel Kant and maybe taking previously, while in case of Kant he somehow had a maybe he how he saw logic was also maybe the Aristotelian way, the syllogistic understanding of logic, and how the Aristotelian how he the very basic statements which included, so how Kant also improvised on those very things, with maybe Leibniz adding the maybe for example in the scheme of statements of Aristotle logic, for example, either a thing is or it is not, or a statement cannot be true and it can be true, either true or it cannot be true, or a thing is or is not. And to it maybe Leibniz added that identity of indiscriminables. So starting from these very and maybe Kantian understanding of logic, where somehow he took Kant took Aristotelian logic and he supplemented that logical scheme with his idealism, philosophy in idealism, where the notions of whether space and time are priori, a priori, and how maybe the constructions of logic thereof. Uh, so within these developments, maybe Russell had a particular way of looking at Fregean way of looking at things, of things seeing logic through the seeing mathematics through the logic of prism of logic, and the binaries and classifications of priori, a priori, synthetic, analytic. Uh, Deviation from Kantian scheme, maybe coming more closer to Leibnizian and Fregean understanding of arithmetic, he could he You could, if you see certain passages, for example, in trying to, for example, the very additivity of arithmetic. For example, when we say that 1 plus 1 is equivalent to 2, so Russell famously in his Principles of Mathematics said that in the capacity of pure logicians, we can say 1 plus 1 or 2, but can Aristotle and maybe Plato be 2? So, what he wanted to convey by that very statement is that the very notion of number, how do we characterize number, and when we impose certain, what I should say, when we impose certain operations like addition, subtraction, or simple rules of algebra, so how how can it be considered valid if we take it, if Aristotle and Plato, maybe two philosophers, they are two people, so can we add them in that sense? So in that process, he somehow came very closer to revisiting the notion how we define number. So famously, we say, he says that number is class of all those classes which are similar to it. And what's a class? So before I'm going to just coming to the way he started with the numbers, how he tried to arrive at the definition of number, and how he extended the system of Fregan way of logicizing arithmetic, but and how he arrived at the notions of how he saw symbolic logic in its ultimate as a base by which we can derive maybe arithmetic as well as other branches of mathematics also. So here I would rather maybe I'll quote some of the statements of how Russell, for example, uh, the conclusions, for example, of Russell and Frege. Maybe what Russell says that laws of arithmetic are analytic judgments and consequently a priori. Arithmetic becomes simply a development of logic, and every proposition of arithmetic a law of logic, albeit a derivative one. So to apply arithmetic in the physical sciences is to bring along to bear the observable facts, and calculations become deductions. So, which I was saying, the laws of number are not applicable to external world. They are not laws of the world. They are laws of the nature. They assert connection between phenomena, connections between judgment and among judgments are included laws of nature. Do not flow from principle of logic alone. So if they do not flow from the principle of logic alone, so when we characterize, so there comes the notions of priori and a priori, or logical statements, analytical statements only. Because if there are analytical statements, so you need not to add a priori. Logic plus something defines, should not define mathematics. So in the larger scheme of how we try to define mathematics in terms of logic, means there's a logic plus some a priori thing which will construct, which will be a synthetic part of that very thing, synthetic statement. So 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 should we add, how can we define mathematics in a way such that the analyticity is a priori, or the synthetic judgments or synthetic statements of mathematics, which may include logical statements, should we add something a priori to them or not? So this is one question to it. So before he is what coming to symbolic logic, so there are, so for example, he said that do not follow from the principle of logic alone. And the perception of this fact led Kant to his innovations in the theory of knowledge. So, since the growth of known, so this I have talked. So, so what maybe before coming to it, for example, but for the, so all mathematics flows from symbolic logic. B, what are the properties of symbolic logic? So now coming straight away to what symbolic logic is, or how symbolic logic has some relation with the other branches of mathematics, arithmetic included. Uh, Before Russell and Whitehead came, maybe Russell historically, Russell was also maybe influenced by the book of Whitehead on universal algebra, as well as when he wrote Principles of Mathematics, and before coming to his Principia, project of Principia. So these things, maybe there was active collaboration also with Whitehead. So they came to by series of certain developments to this how symbolic logic can ultimately be the bedrock of his constructions of mathematics at large. So the study of various, for example, symbolic logic. What is symbolic logic? The study of various general types of deduction. The word symbolic logic designates the subject by an accidental characteristic for the employment of mathematical symbols. Here, as elsewhere, is barely a theoretically irrelevant. Symbolic logic has become not only absolutely essential to every physical philosophical logicism, but also necessary for the comprehensions of mathematics generally, and even for the comprehensions of, and even for the successful uh, practice of certain branches of mathematics. So this is a statement of Russell, maybe in Principles of Mathematics or somewhere else. He is saying the he's giving us the reasons why we are invoking symbolic logic. And what he further says, what he is called induction appears to me to be either disguised deduction or a mere method of making plausible guesses. The particular notion which appear in propositions of symbolic logic or logical constants, the particular notions which appear in propositions of the subject of symbolic logic consists of three parts: the calculus of propositions, the calculus of classes, and the calculus of relations. So this is how he tries to see symbolic logic in his scheme of things. If you read Principles of Mathematics, he has devoted many chapters of how we characterize proposition, and how we define relations, and how we define also classes. So here, before coming to the point of how maybe in trying to understand the notion of classes uh, and the relation between and classifying classes, how maybe Frege, and maybe there is a curious and interesting is how Frege and how Russell maybe arrived at certain paradoxes famously called in literature, maybe Russell's paradox, Richard's paradox, and other paradoxes which somehow in a way somehow his the notion of how he tried to understand these paradoxes, maybe they led to some other developments also, but maybe that led to how we can define a certain class, and there and how he arrived at maybe theories of types, theories of descriptions, and other things. So before coming to that, maybe so maybe mathematics in and and behind. So in the logicism which Russell was converted to at that point in time. So which I'll just try to say. But one statement, for example, says that Russell, which will characterize how we characterize logicism, his faith in logicism. So Russell took over a logic of propositional and predicate calculi, added to it logic of relations, predicates of more than one variable, and thought that all mathematics could be derived from such resources, not merely methods of reasoning required, but also to objects. Presence of logic, for example, foundations of, so in not only maybe Frege have, there are people like Piano and Cantor, for example. So the presence of logic was also raised in that he considered systematically the necessary or sufficient conditions for the truth of theorems. However, he did not treat logic explicitly. So, in the process of, for example, logicism, maybe the logicism of Frege and logicism of Russell, there is a difference. Maybe Frege was logicist in arithmetic only, maybe, and Russell wanted to extend that logicism to other branches of mathematics also. So, for example, Russell was logicist about arithmetic, Frege was a logicist about arithmetic, while Russell had a stronger thesis. So, for example, in his book, which I cannot pronounce, Briggs, Frege's book, and there's his book of Foundation of Arithmetic also. So, for example, he in the first, if the first part explains in Frege's analysis, first part explains logical symbolism. The second part shows how to represent and derive certain propositions, and third uses symbolism to provide an analysis to the mathematical induction. So this is his methodology. First, how you symbolize things, and then how you give meaning to those symbols, and the deductions thereof. Maybe those deductions maybe provide an analysis of mathematical induction or mathematical induction. Maybe that's the thing. But in principles of mathematics, maybe Russell has given a very whole how he has. So there are certain maybe subtle differences. For example, if I say how logicism of Russell and logicism of, for example, Leibniz. So, for example, Russell argues that Leibnizian philosophy follows the logicism of Russell and logicism of Frege. So, logicism of Russell argues that Leibniz philosophy follows almost entirely from small number of premises. Leibniz demands truth in two categories: primary truths and secondary truths. The former he characterizes especially logical truths, those which either state a term of itself or deny an opposite of its opposite. If maybe that's it, maybe Leibniz. So that's it. So So maybe the side statement to this is that the developments in, for example, maybe logic, maybe they somehow initiated developments in other branches of maybe looking at mathematics. Not only the subject is called metamathematics, foundations of mathematics, or metageometry, foundations of geometry. So it also led to series of developments which might have maybe, for example, which, for example, the development of axiomatic theory, especially with the help of maybe it also somehow initiated other developments, or it somehow influenced maybe the grand program of Hilbert of trying to axiomatize whole of mathematics, and even in for example, people like Carthy and Clausius, who even tried to axiomatize laws of thermodynamics also. The the axiomatization or formalization project of Hilbert and other people was also in somehow there was an not a dialogue, as well as there has been the developments in one have influenced the developments in other in a significant way. Maybe later, well, I'll talk of how the Godelian program of the arithmetization of logic, which was somehow shown to be fundamentally inadequate or incomplete within the larger, the whole arithmetization of logic as a program, when it was shown to be uh, failing in which was shown to be incomplete, or uh, in some senses somehow it also had some influences on the grand project of axiomatization of mathematics also, willy-nilly. For example, the notion that proposition may be established as the conclusion of explicit logical proof goes back to ancient Greeks, who discovered what is known as axiomatic method and used it to develop geometry as a systematic fashion. Maybe this is not related to it. Maybe. So before I'm coming to what how Godel and other developments have been developed, but I would rather say that the important part of that Russellian understanding of trying to see what is number, and his famous definition of a number is that number is class of all those classes. So there are certain paradoxes which come, for example, that of the paradoxes of self subset of self-membered set. So if there is a universal set, can it be self-membered set? So it led to some paradoxes in the sense of, for example, if can self-membered set be subset of its own self? So if it is subset of itself, so how we define it? So it will lead to some contradictions, like that for example, barber's paradox, that if barber shaves in the all people in the village, does the barber shave himself? If he shaves himself, he is not part of that village. So he is not member of that village. If he shaves, if he so so does, so this is a paradox. Or like liar's paradox, that for example, people were knowing that this statement is not true. So if you say it's not true, this means it is false, but if it is false, this means it's true. So these things, this flopping of true false, so it will, you can say those are paradoxes in the Russellian sense. Somehow they had a very significant influence on how we described maybe universal sets or self-membered sets, or for example, in common sense examples, for example, there are two thinking people, uh, one thinking people, so two thinking people, do they make a larger set of uh, thinking people? But the same cannot be extended to, for example, if two, for example, two things can they in conglomeration, in aggregate, make the set? Does it carry that sense also? So that these very developments in of Russellian paradox, and how it led to certain contradictions. So they have had a significant influence on how we try to define the foundations of mathematics, and even the later developments of Cantor's theories. So how? So maybe in the history of development of mathematics, it's interesting in the sense that the way Cantor tried to categorize, he tried to define infinities, and he found that some infinities are bigger than other infinities, and there are some antinomies, and how he tried to associate them. And the maybe developments in analysis, where how we define that dedicant cut, and how we try to define the number line, and the famous Richard's paradox also, that if something is defined in relation to something, so for example, if it is defined in relation to that thing not being there, so if it's not being defined in that thing, that it's not being there, it's defined with reference to something. If A is defined with regard to B, presence of B is defined if A is there or not. So maybe, which I'm not able to properly explain, there are maybe huge it needs a bit of sitting and maybe thinking and getting confused and getting confused and coming understanding and come, and maybe needs a bit of initiation and bit of introspection, or to maybe see how these subtleties of paradoxes, from Russell's paradox, Lair paradox, means Richard's paradox, how these paradoxes also have defined the, how we define the set numbers, and how those very numbers, if you relate also logic with the numbers, and how we define them with the analysis, how we construct a number line. And there are various axioms of continuity, axioms of reducibility, and which leads to whole plethora of or Pandora, I will not say Pandora box, it opens the other debates of set theory. So whether set theory is can be understood as a branch of logic, is a subset of logic, or logic, so the difference disagreements regarding that, and the various developments like Zermelo Franklin set theory and axiom of choice and paradoxes associated with it. So paradoxes, or how the subjectivities of mathematicians come into play with regard to giving value or to the different assumptions of when we take with axiom of choice or other things, and the differing things. So it also is a huge debate which has continued. So the point, even in the sense, even though the statement of, for example, Hilbert, that nobody can take us from the paradise which Cantor has created for us. This means even in times of Cantor, a lot of mathematicians, in particularly, for example, maybe Poincaré, who said that maybe future mathematicians will come out of that disease. That disease will be cured in future, which maybe the world paradise, which the field of mathematics which Cantor was working on. So he considered it as a disease or malignancy which will be cured with regard to time. But maybe Hilbert had a very different opinion about the same. So what I wanted to say is that the developments of Russell, how he tried to define the Russell's definition of number, of self-membered sets, and Richard's paradoxes, these things have, in a way, the subjectivities of mathematicians and the different viewpoints. It has continued even up to this time. Maybe different subjectivities of mathematicians will give different assumptions of axiom of choice, or those very axioms, they will give different value to them, and the corresponding, what I should say, conclusions may also vary depending upon subjectivities regarding the same. Maybe one thing, maybe I have not, which I'll try to talk of, maybe important thing is that how in some fundamental way Russell tried to describe his analytical method. So how he tried to define his analytical method with regard to his um, he his so before trying to, for example, so how he tried to analyze things, because if you there are very interesting there is a very interesting topics. The principles of mathematics is a very dense terse book, in the sense that there are a lot of chapters. For example, whole and part is one good section, whole and part, so propositions, symbolic logic, so they are related, but some of the things, maybe in whole and part, there's one chapter. So how he tried to, so so when he is famously, maybe Russell said or some, that the parts of the whole in the whole are more than the parts in the whole in the parts of the whole are more than wholes. So if you say whole is made up of parts, and parts in themselves are wholes. So what the way he wanted to convey is that whole is more than a sum of parts in the conceptual sense. Means there is something more to it. More to it is how he tried to have construct basically the idea of analytical method, the analysis. And for example, when he says, ever since I abandoned the philosophy of Kant and Hegel, I have sought solutions of philosophical problems by means of analysis, and I remain firmly persuaded, in spite of some modern tendencies to country, that only by analyzing is progress possible. We may distinguish three core models of analysis. For example, regressive modes. In the how we define in the regressive mode, identify the starting points. There we identify the starting points in terms of maybe principles, premises, or causes. So something can be explained or generated. This is regressive mode. The second is the resolutive mode. Constitute to be mode to identify the elements of something and the ways that they interrelate, and then how in the resolutive mode we are considered to identify. So the way we try to symbolize, for example, we start with prepositions, we symbols, we give meaning symbols, and then we have inductions or deductions thereof. So this is one. So in the same way, in the analytical method, you identify the starting points, which are principles, premises, causes, and the second is the resolutive mode, concerned to the identify the elements of something. So you identify what are the meanings you give them to, and the way they interrelate, and the interpretive mode, concerned with translating something into a particular framework. So you have an regressive mode, then resolutive mode, and then you give meaning to those very symbols. So the regressive mode has its his roots in the ancient Greek geometry, and has significant influence throughout the history of philosophy. The key idea here is that of disclosing and or working back to first principles by means of which to solve a given problem. For instance, a particular geometrical figure. So, so the regressive method of discovering the premises in mathematics. So process of working back to ultimate logical premises, a process that is inductive rather than deductive, aimed at finding the irreducible minimum of assumptions, by means of which the more obvious truths from which we started can be deduced. However, it's not regressive but a resolute mode of analysis that dominated concept of analysis in modern period. Resolutive analysis concerns whole part and function argument analysis. And decomposition analysis consists or was defined as discovery of constitution and manner of combination of given complex. Given the Russell's initial preoccupation with Bradley, not to mention, for example, he says British traditional and analysis presupposes a particular framework of interpretations. For example, there is a statement of maybe Wittgenstein also. Uh, Relation of Wittgenstein to Russell is very interesting also, in the way Russell's enthusiasm towards logicization of mathematics, the faith in it was partially shattered by his interaction with Wittgenstein. And for but Wittgenstein here is somehow appreciative of Russell. For example, in Tractus, Wittgenstein commended Russell for having shown the need to distinguish between the grammatical form and the logical form. The grammatical truths and logical truths may not necessarily be, you cannot maybe exchange them. Maybe these doctrines of logical atomism and other things, maybe those things are well discussed. So while Russell understands resolution in whole part terms, in terms of decomposability, for Frege, function argument analytic took center stage, although this was often glossed in whole part terms. So there is a good section of whole and part in Principles of Mathematics where he has tried to allude to those very things. So how we will maybe uh, so how we will I'll again come to the difference of logicism of Russell and Frege. For Russell, logicism, if logicism is correct, then the theorems of some or all branches of mathematics will turn out to be proper subset of the theorem of logic. So Russell favored the more universal form of logicism. It is logicist's goal to show that, this is what Russell says, it's logicist's goal to show that all pure mathematics follows from purely logical premises and uses only concepts definable in logical terms. So there is a first order logic, there is a first order logic, second order logic. So maybe in theory of types, Russell's theory of types and how he addresses them, or theory of descriptions. So it's in itself a branch of study, but maybe in first, for example, the way there is first order logic, there is second order logic. For example, mathematics is reducible only to second order logic, and that second order logic in turn is equivalent to set theory. So it would remain unclear just how helpful such reduction would be, either ontologically or epistemological definitions. Maybe this is what I was previously saying, now how the puzzles of or paradoxes of Russellian paradoxes and their relation to set theory and the process of axiomatizing of mathematics or logicization of mathematics, so the problems thereof. Uh, so so how much ontologically and epistemologically that endeavor is worth it or not. So the way so this is Russell's logicism for it, but in Frege's logicism, it's important to realize that primary motivation was epistemological. He wanted to secure the a priori certainty of arithmetic. His primary aim was to show that truths of arithmetic were absolutely certain in virtue of being founded upon and derivable purely from logical axioms and suitable definitions. So inextricably linked to this goal was the eradication of psychological and what amount to much the same thing for Frege, subject to elements from the notions of truth and proof. Maybe there's also another maybe the connection, the way there's how Frege saw logic and how Russell saw logic, but there's also a relation of how Russell saw logic fundamentally in his earlier stages before the developments of Gödel and other things. That how how Russell saw logic and how Wittgenstein saw logic in the fundamental how we want to reach at fundamental truth or reality or whatever you want to construe. Not only Wittgenstein but Poincaré also. Maybe for example, if you take Poincaré and Wittgenstein, so their views somehow partly overlap. For example, in relation to Russell, for example, it's unlikely that mathematics should gain its sole epistemic justification via logic. Some parts of mathematics are themselves more certain than and are known often independently of the requisite body of logic. So that the epistemic content to mathematics is that the mathematics as a subject is more than as a branch of logic. So maybe so you have logic, but So it's not the truth or value or the epistemic content of mathematics cannot it only be reduced to logic only. You can there's something more to it. This is the statement of Wittgenstein and Poincaré. So an empirical premise is a premise which is of epistemic value, that is from so this is what it is a which usually maybe there is, for example, there is another statement of, for example, maybe Russell, and which I have forgot. Maybe, what I this is the thing which I just wanted to. This will elucidate the very approach of these two people, how they saw logic as a fundamental inquiry of truth. Whether the logic is a tool, or logic is an end in itself, or a means to end. So these are two approaches of seeing logic. For example, Russell saw logic as a skeletal enterprise of classifying and identifying moons beneath the beliefs, and within which list of coherence applies. Whereas Wittgenstein took logic to be itself a scaffolding, to be taken up and down, just like the scapels of that surgeon. So, up to, logic to be a scaffolding to be taken up and down, and aid in the construction of pure depiction of reality, but not itself in the business of studying what actually is. So maybe Russell gave logic more value to it in the maybe the ends justify the means. Maybe the logic, he give logic. So he the use of logic as an end in itself, and use of logic to attaining to reaching something else. So these are two fundamental differences of how Russell saw logic and how maybe Wittgenstein saw also. And maybe there's another thing, maybe I'll just these quote, for example, Russell revisited the notions of in later, for example, the earlier Russell had a tremendous faith in logic as a tool, but later Russell, with the developments of Godel and criticism for Wittgenstein, maybe that was partially shattered. And in the meantime, you could see that he shifted here and there. He just somehow, what I should say, engaged himself with these doctrines of neutral monism and linguistics. But how he saw it, maybe this is a statement or which is he is not, he's not logicist to the core, but he wants to instill rehabilitate logic, the value of logic. For example, Russell revisited the notion of truth and meaning in the light of neutral monism, and several of his arguments that metaphysics cannot be wholly turned on the idea that the foundations of mathematics must be philosophically related to the foundations of psychology and the theory of meaning, but in such a way that notions of truth is not reduced merely to psychological or linguistic notations. So maybe these are other developments he wants to uh, or cannot be whole trust. Foundations of mathematics must be philosophically related to the foundations of psychology. So maybe earlier his only aim was of logicizing mathematics, but now his definition of mathematics would be that they are also related with the truths of psychology or truths of linguistics in the theory of meaning. But the aim is that, but in such a way that the whole truth is not reduced to merely psychological or linguistic notations. So here, linguistic notations mean the way of Wittgenstein, of maybe mathematical statements or tautological statements agreed upon linguistic rules. So, so here maybe he is partly not agreeing with Wittgenstein also in his understanding of mathematics. Uh, so maybe uh, maybe the formal construction of how he tried to Uh, it's a huge program and project of how Russell saw mathematics or the journey. So Principles of Mathematics, Principia, first part, second and third volume. So it needs a tremendous investment. So to give you to it, so that you have a flavor of what how the program of Russell is, of logicization of mathematics is. Not only Russell, Whitehead included. Maybe the these developments, they had a significant influence in how we defined mathematics also as a whole. Because now I'm going to connect it is the contribution of Russell was in the sense, one is logicization of mathematics, but maybe maybe I would not say I would say that the how the developments of maybe logicization of mathematics, how that very thing influence fundamentally the Godelian influence on mathematics, and maybe Hilbertian influence of maybe axiomatizing or formalizing mathematics on the whole. So these two developments, maybe they were in active exchange of how Russell and Whitehead had pursued mathematics in the earlier part of the 20th century. And the case of Godel being that Godel was maybe influenced very much apart from his readings of Russell in mathematics. He before he wrote the famous paper of on formally undecidability of arithmeticals and other state systems in the Principia Mathematica, he was also aware or in reading the other books of Russell, maybe Analysis of Matter, Inquiry into Meaning of Truth, Analysis of Mind. He had kept himself abreast with these very developments, and maybe somehow somehow maybe the philosophy of Godel was more Platonist. He would want to, was consciously trying to say that his way of looking at mathematics is not entirely that of Russell also. So he had a more Platonic way of looking at mathematical forms, and so his predilections were to that very directions. But be what that may be, but what I wanted to say is that the important thing, maybe Russell vis-a-vis Goodale, vis-a-vis how Bertrand Russell's interface with Goodale via logic, set theory, and philosophy. So it's also very very interesting in the sense, maybe in the sense. So maybe, for example, I'll just read how the methodology of principles of mathematics. The construction of mathematics out of logic is carried in principles of mathematics. Sorry. The construction of mathematics out of logic is carried out by first developing arithmetic through the definition of cardinal number of classes as a class of classes, which is similar to it. Then the development of analysis is carried out by defining real numbers as set of rationals satisfying appropriate conditions. The main difficulty in reconstructing Russell's logic at this stage consists in the presence of logical notions mixed with linguistic and ontological categories like denotations. Moreover, Russell does not present his logic by means of formal language. So he has used the way of symbolic logic, how he uses symbolic logic and his theory of types and ramified theory of types also. So now I'm coming to his very maybe Russell's what I was talking of, the idea of, for example, So what I was saying that the Godelian influence, which we talk of, the the earth mystization of logic, which was he proved it in a strict sense that it was not possible. So he this development was influenced strongly. You can trace it to Principia Mathematica, the proof of Godel. And maybe there is also a nuanced reading of good, what I was saying. Then he was consciously trying to. He was nuanced. You can be there can be nuanced apart from the technicalities of studying the proofs. So there is also the interpretation of what we got. Uh, so how you see that very thing, how it changed our understanding of looking at mathematics on the whole, because it is also somehow linked to the fact, maybe godalization somehow, the way in physics we have uncertainty principle. Uncertainty principle, in a sense, it also shows our inadequacy or limitations to assess nature at some fundamental level. Within the limitations of uncertainty principle, we can assess nature in within that the position, momentum, or energy time conjugates. There is a limits. There are fundamental limits we can know nature. So there is a bound to it. So in the same way, the Hilbert, the Godelian program of showing that Earth metasization of problem of mathematics, of logic, is not possible. Somehow it also led to some blind spots that we cannot. Maybe there also is a debate of consistency. There's also debate of completeness, and there's also thing of. So if we want to formalize a system, can we show it to be complete? So if you want to show that it is complete, can we show axiomatize it? So there is also some fundamental limitations to it. So this in a somehow sense militates the way the rest of the mathematics has developed from last 60, 70 years. Mostly people, apart from developers in computer science, people from mathematical logic. So mathematicians normally don't want that the proofs which they have arrived at. So there can be that the adhosity. The physicists are okay with that their fundamental assumptions, or they can be ad hoc, or you cannot strictly axiomatize them or logicize them to some principles. So they are, the very attitude somehow is discomfortable for maybe the mathematicians when if you take that we think seriously the results of godalization, that the arithmeticization of logic is not possible for any formal system. If you have either you can show it is consistent, or either you can show it's complete. You cannot do both simultaneously, because in a given system there can be already, if we try to prove a certain thing, but there can be, it's an open-ended system. Within those very statements you can have statements by which you cannot so there is something called decidability. So can you decide, uh, can you fix the problem there and then? So Godel, in a significant way, he within the proofs of his, he showed that it's not possible. That very things is not possible. So the um, the that we think is not possible. You cannot logicize or arithmetic, and in the process you cannot either formalize uh, a system to the first principles without maybe the axiomatization and maybe no, sorry, the consistency and completeness, they don't go side by side. There is some fundamental limitation to it if we study this Principia Mathematica. So even so you cannot even So maybe these debates are also related, not only completeness, consistency, decipherability, finitude. So can it be finite? Matlab, can we, for example, a given maybe this Godelian thing? Maybe people from computer science like Turing and Turing's faulting Chaitin, they have taken. So can we take a program and it's somehow going to halt at some point, not in an open-ended way, such that the solutions may be, but it's decidable. So in that sense, maybe the developments of Godalization of maybe mathematics has in a sense shown us that the that logicization of mathematics as a project is also not as a possible in terms of methodology also. So that will in a some sense share some fundamental maybe truth content, or how do we fundamentally construe truth content of things, how to just can construe them at a fundamental level. And maybe so now I'm going to maybe conclude. Before I'm going to yes conclude, I want to say something. For example, maybe uh, so I'll just again try to come to the origin of how we try to define mathematical. The word mathematical logical. The word mathematical logic can be used with two different meanings. On the one hand, one can treat logic mathematically as it was done by Schroeder in algebra of logic. On the other hand, we can investigate scientifically the logical components of mathematics. The first approach is tied to the names of Boole and Schroeder. The second was represented by Frege, Peano, and Russell. Maybe if Russell is not alone, maybe he is in continuation of other people, including Whitehead and Boole, and maybe Leibniz also, and uh, and maybe what I should say. And further, what is the mathematical logic is to a microscope which is appropriate for observing the smallest differences of ideas, differences that are made imperceptible to defects of ordinary language in absence of some instrument that magnifies it. So this is also one way of looking at it. The way we have a microscope or experiment, whether a telescope or a microscope to see things. So the maybe even the way we define logic is normally a normative science. So the art of reasoning, how you correctly reason things, or what are the rules of reasoning, so that those rules of reasoning should lead us to the correct conclusions. And in the may or haze of lopsided reasoning or a lot of things, the logical way of logical analysis or synthetic synthesis out of that should maybe clear things for you. Not only for Russell, maybe there is a logic to science, larger science also. So what I was maybe I'll come back to what Godel and maybe Russell and its developments. So I'll maybe try to maybe conclude with how we Russell tried to develop things. Maybe the role of Bertrand Russell in trying to carry the project of Frege, Boole, going back also to maybe Leibniz and Whitehead also, to logicize arithmetic, and then having the same faith of earth logicizing the different branch of mathematics and mathematics as a whole, which is very well maybe articulated in his book Principles of Mathematics, and maybe it's the shorter book Introduction to Mathematical Philosophy, and which was later taken by Whitehead and Russell in that very magnum opus, 3 volumes, 1, 2, and 3, trying to, like, it was a very grand and significant, not, people are saying, a significant achievement since the time of Aristotle. So even to that, it is a towering achievement in that sense. But and maybe Russell not only developed that attitude, he just branched that, he had enthusiasm of uh, developing that logicization program to another other branch of knowledge and knowledge itself, which he had articulated later in his book. But even in the process of the when it reached its zenith, even the post Godelian developments of showing that non arithmeticization of logic is not possible. So even in its those very developments also had significant influences on the way mathematics, the foundations of set theory, how they the debate somehow shed light on how we define mathematics also as such. So these developments were fundamental. Yeah, these developments have somehow had influences not only in computer science, logic, maybe different linguistics, even the very whole faith of having a faith in logic. So that is a worth. That's an endeavor. Even historically also, maybe the project is project is in a sense, I'm not getting the proper words, I would say. So it's worth investing time to at least have a view of it.